In a world of fragile democracies, it's very important that policies be based on reliable and robust knowledge. And I think choosing the climate as an example of what are the challenges that we are facing and what has been done and what still needs to be done is a very good choice. I want to focus this small intervention of mine in three basic topics. First of all, what do we know about greenhouse gases? I mean, how long have we known this? And how we've come to that knowledge. The second is what is actually happening today. What are the things that are occurring that are a result of the increase in the levels of not only CO2 as a greenhouse gas, but many of the other greenhouse gases. And finally, ending in an optimistic tone, talk a little bit about what has actually occurred in order to address some of those challenges and actually what still needs to be done. And there's a lot that needs to be done to address them. Starting with the first topic, which is, what do we know about CO2? The first person who actually discovered the fact that CO2 and actually also water vapor were greenhouse gases was a woman, a citizen scientist. She was not an official scientist. She was interested. She mounted a laboratory in her house. And she was the first person in the mid-19th century, talking about almost 170 years ago, was the first one to demonstrate that CO2 was a greenhouse gas by a very simple experiment. She filled a tube with CO2 and another one with air, and she put them in the sun, and she saw that the one with CO2 increased its temperature more than the one with air. She did the same thing with water vapor. And because she was a woman, she was not allowed to actually talk about her results at the AAAS meeting in the United States. It had to be a man who did that. It happens that a few years later, 3, 4, 5 years later, the people who are now recognized as the discoverers of the greenhouse gas, John Tyndall and then Sven Arrhenius, sort of repeated her experiments now in a more controlled laboratory. And so they are the ones that are known as the discoverers of the greenhouse gas effect. In the meantime, so we've known for 170 years, that's a very long time, that CO2 is a greenhouse gas. What actually happened later in the mid-20th century was that John Revell, who was the head of Scripps, started noticing that the CO2 levels in the atmosphere that were known did not correspond to the ones that were produced by the consumption of fossil fuels. So she hired a young man called Charles Keeling to start measuring the CO2 levels in the atmosphere. And we have probably the most famous curve of data that was collected by Charles Keeling and then was continued by his son, that were measured in the top of one of the islands in Hawaii, which showed, in fact, that CO2 was increasing. It oscillated. It was a maximum after winter when people had to heat their houses in the northern hemisphere. But it continued to increase at an increased rate along these years. And in fact, today, the data that we have on the levels of CO2 are, as I said, starting in the late 50s of last century, so almost 70 years ago. Now, at the moment, at that time, people were aware that because this was predicted by John Tyndall and Arrhenius, that a doubling of CO2 levels would result in an increase of about 5 degrees centigrade of the temperature of the Earth. So we've known this for a very long time. And it was, in fact, about 28 years or 30 years ago that people decided that this was a global problem, and so it required global interaction and global decision-making. And that's when the Conference of Parts started, and we are now going to have at the end of this year the 28th, I think, Conference of Parts. And so we've had one almost every year for the last 29, 30 years. And what's curious about this is that so many countries have participated in these so-called COPs, and yet CO2 levels are today increasing at 3 times the rate they were increasing 30 years ago. So in spite of the fact that we've known so much about it, there's so much data regarding these effects, we still have very little that has been done to try and slow down the CO2 increase levels. Now we also know that there are other greenhouse gases for which new, very sophisticated measurements have also become available. So we know methane is also increasing. Methane is a much more powerful greenhouse gas than CO2. Fortunately, is at much lower levels. Now, what's interesting is that we've known this for so long, and all the predictions that were made, all the predictions in terms of the increase of temperature of the Earth, all the predictions that had to do with extreme events are all taking place more and more frequently. So we now know that all of the things that have happened this year, it's just been recorded. This will probably be the hottest air since they were starting to be measured. All of these things were predicted. There were simulations made. We've known this for a very, very long time. And so the question is, why? Why is this continuing? And why, to some people, it seems that so little has been done to deal with this issue? And of course, the reason is very simple. There are many interests involved. There's a whole economy based on fossil fuels. There are many, many countries that depend heavily on the fossil fuels that they have. And so it's very hard to change that. It's very hard to change the way people decide to live and how they consume energy in their own house, in their own city, in their own country. And in many places, it's almost impossible. They don't have the technology. Many of the developing nations don't have the technology to start buying electric cars, to start getting, renewable energy, sources of energy developed. So it's a very difficult situation. And we see that there's a lot of pressure being put, but we also realize that in fact, many of these people in the so-called developing world or the people in the developing world would like to have the same quality of life that we have. They'd like to have comfort, they'd like to travel, they'd like to have their houses cooled in the summer and heated in the winter. And so it's very hard for us to say, you now have to make changes when the fact that CO2 has increased has been the result of the developed nations. It's sort of, if you want to put a blame, which is always very hard to do, the blame is on those like Europeans and Americans and Japanese and the areas that have a lot of fossil fuels. They're the ones that have produced this problem. So how do we deal with this? How can we address these issues? And I think there are 2 or 3 things that we need to do. First of all, we need to realize that we have to adapt. Things are changing so fast that it's not possible to deliver the technology and to implement the technology all over the world to reduce this increase. So we know there's going to be climate change. We need to adapt. The second thing, of course, is to try to develop even more sophisticated technology in order not only to reduce the levels of CO2 emissions, but how to capture CO2, how to store CO2, how to use CO2 in order to produce other products, other materials, which is now happening almost in many places of the world. A lot of scientists are looking at ways of using CO2 to do other things with it, to produce new materials. And so it's going to take time, and that's why we need to know how to adapt. I want, however, to end on a positive note, because I think that we have a tendency to think that, this is, it's out of our control. This is going to be a catastrophe, a disaster, and it is if we don't do anything about it. But I think we have a number of examples in the past which show that we have been able to deal with some of these environmental challenges. The issue of acid rain, for instance, it was a big issue, 50 years ago, people were talking about acid rain because it was also a non-local problem. It was produced somewhere, other people had to suffer it. Nobody talks about acid rain anymore. It still is there, but it doesn't have as much of an impact. The ozone hole. We still have an ozone hole, but it's getting smaller. The issue of lead in gasoline, lead in paints, lead, it's gone. The issue of the importance of lead to health of humans, it's no longer a topic that's being discussed, at least in the developed world. The issue of mercury and cadmium, that was an important one in fisheries in Japan, it's being dealt with. The smog in London is gone. There's now smog in other cities, but we know how to deal with smog. And also, the number of new technologies in order to reduce the production of renewable energy is amazing. Now renewable energy is competitive with fossil energy. This is all the result of new research, of new technology. And so in my view, I think, we have to be concerned, of course, and many people are, thankfully. It's going to take time, but I've always been an optimist, and that's what I'd like to leave with you. I believe that it's not going to be easy. I believe that we'll have to consider the climate as something which is the right of humanity, if you want. You need the idea of having as stable as possible climate should be one of our rights. And I think we're going to end there at some point. It may take 10 years, 20 years. Fortunately, the population is also not increasing at the same rate, so we might be able to get there.